Harvey Mudd College and a PhD in climate science from the Scripps Institute of Oceanography. And with that, I will turn it over to Guillaume.
More detail than anybody wanted. Okay, so as Julie said, we're collaborating on this climate resilient floodplains project, and so she's talked about the interviews and sort of trying to get a real a start to understanding what actually people need in terms of information for how to incorporate climate change into planning. And I think, like you put it really well, this is a start, right? We're sort of scoping out what's needed. We're really just getting our feet wet on this. The other piece that we've been working on, two pieces, is how do we've got lots of information, lots of research, lots of data that's been collected or put together on how climate change may impact floodplain management writ large. So that's beyond just flooding. It's also when you start to think about watershed scale planning and try to really do this integrated multi-objective planning where you're not just thinking about protecting cities or infrastructure, you're also thinking about habitat, you're thinking about agriculture, and you're maybe thinking about tribes as well. How do you put all that information together and into a planning context and think about it more holistically, right? So a piece of that project was to just go out and synthesize what the literature says on climate change and impacts. And that's mostly what I want to talk about. I am, now that I've said that, going to focus on sort of, just in order to have a talk that's not too long or too rushed, on the climate change impacts on flooding. But the synthesis covers, in fact, I've got a slide. So we're calling it the State of Knowledge Report on Climate Change Impacts in Puget Sound. And it covers everything from the uplands, including wildfire, snow, that sort of thing, all the way down to the marine waters of Puget Sound. And it really is intended to be a state of knowledge synthesis of what we know at this point. And so in that way, so in some ways, it's good for highlighting how little we know. In some ways, it's also good for highlighting the important facts that we already have that we can work with. So that's coming out in a week or two, and if anybody's interested, I'll have my email at the end. Email me. I'm happy to send it to you when it is available. So what it includes, I mentioned this, all sorts of topics, and today I'm really focusing on the ones that impinge on flood risk. So I'm just talking about rivers and floods. I'll mention a little bit about landslides and sediment and sea level rise. So when I think about how climate change impacts flooding, I think about sort of this is sort of the rough schematic that I have in my mind, right? So you can think about a watershed. The waters sort of start at the headwaters in the mountains where there's snow. Climate's going to affect how much snow we accumulate in winter and how quickly it melts. Heavy rainfall events are of course going to be important, and then there's everything on the in terms of sea level rise and surge, which can affect the coastal side. So in layman's terms, when I think about climate change impacts, I think about a triple whammy, and just in case you're worried that I can't count, I do know that there are 4 there, but I sort of think of the sea level rise and surge as acting together. And specifically, the research right now is that storm surge itself is not really projected to change. Eric's doing a little bit of research on waves and may prove me wrong in the next couple of years. But in terms of just elevated levels because of lower surface pressure and the strength of the winds that storms are bringing in, we don't see a change. What instead we see is a greater reach of storm surge because there's just a higher base sea level on which it's added, right? So the triple whammy is really the higher sea levels at the coastal end, the lower snowpack on the high end, that's going to increase the amount of water we get in winter coming down the stream, and the heavy rainfall events. And I was just going to walk through these in terms of just to illustrate what we're talking about. So sea level rise. This is coming straight out of our synthesis. So what we've seen for the last 100 years is a little bit over 8 inches of rise in the region. And what we're expecting is on average, about 3 times that over the next 100 years. So there's a wide range among the projections. And just to illustrate what that looks like, this is a nice example. I believe it comes from your King Tides website. And this is showing Alki Beach in Seattle, in West Seattle. And what you're seeing are the railings for a stairway that goes down to the beach. And this is actually one of the nice things about the King Tides website that they maintain is that it's a way you can look at surge events as sort of a proxy for what the average sea level might look like for the same amount of rise, right? So this is actually a 2-foot surge. It's not a stormy day because it's just lower sea level pressure, which is elevating the level. And so you can see what happens with just that 2 feet. If there were 2 feet of sea level rise, you would add surge on top of that, right? So we're starting to get into maybe not the most critical infrastructure, but at least into things that were not designed to be submerged, right? And so then I keep mentioning about the surge and what that does. There's folks that have run numbers. This is from a study in Olympia, where they looked at if you have 2 feet of sea level rise and you add the normal 100-year storm surge event on that, if you look at the probability distribution of surge events, what happens to what we used to call the 100-year event? And so if you add 2 feet of sea level rise, that what used to be the 100-year event is now happening at least once a year. So if you add, and they've looked at the number for other, assuming it's smaller amounts of sea level rise. So for instance, if you look at a foot of sea level rise, I believe it's occurring about once every 2 years, whereas it used to be a 100-year event. So that's an example of the same surge can lead to a more higher frequency of flooding. Okay, so that's the one in the triple whammy. The other one is intense precip, so heavy rainfall events. So the paradigm up to a couple of years ago in terms of when you're talking about northwest climate change was that it's warming. Everybody knows that. That's not a surprise. But that precipitation changes are small in comparison to year-to-year variability. And that's true, but it's only true if you're considering annual or seasonal precipitation. If you're looking at intense rain events, those are the events where basically the dynamics, the weather patterns, are doing everything they can to throw as much water at us as possible. So when you crank up the temperature, you're putting more water vapor into the atmosphere, and you're going to see a much more rapid increase in the intensity of those events. So with those events, we expect to see those emerging from the year-to-year variability in the early part of the second half of the century. So just to be specific, if you're looking at the end of the century, you're talking about 22% increase, or another way of looking at it is a higher frequency. What we used to call the 99th percentile event was happening 2 days per year in the past, and it's going to be happening about 8 days per year at the end of the century, so 4 times as often. Okay, finally, the snowpack. So this is something that probably a lot of you have heard about in past talks or conferences. It's a big factor in our region, and the reason it's a big factor is that we have a lot of quote-unquote warm snow, a lot of snow that's near the freezing point. So small increases in temperature or large increases in temperature, as the case may be, are going to make a big difference for how much snow we can accumulate in our watershed. So specifically, we're talking about, we've already seen, if you look at the past, 1950-ish to now, about a 25% decline in the amount of snow in the mountains. What we're expecting is more than up to more than half of that remaining going away again by the end of the century. So why is that important? What that does, as many of you know, snow acts like a reservoir, holding water for summer and keeping it out of our rivers in winter when we don't want it. The opposite happens as we lose it. We get more water when we don't want it, when flooding is a problem, so flooding risk goes up, and we get less when we need it for fish and that sort of thing. So those are and we have a lot more detail fleshed out in the report, but those are the basic factors, the big factors affecting flood risk. So I want to mention a couple other details that are important when thinking about really trying to quantify what we know and also how we can, the information that we might be able to use when we're thinking about planning for changing flood risk. So one is natural variability. 2015 is a great example. There's ongoing research about to what extent climate change was a factor in driving the incredibly warm conditions in 2015. But from what I've seen, it really looks mostly like it's a fluke. So it's natural variability is the predominant factor driving why it was warm in 2015. And that kind of year-to-year variability is going to go on in the future, right? That's not going to stop with climate change. So that is a really important factor when you think about when we're talking about with planning, right? For instance, in the previous session, we were talking about culvert design and how those can be designed for climate change. And it's not enough to ask what is the average projection or even the range around the model projections from that. You got to also factor in the fact that there is going to be this variability. So an example here is looking at the length of the ski season, actually. I was looking at the ski slopes, Snoqualmie and Baker, and about how many days per year you could go skiing. It turns out it's decreasing, obviously. Snowpack's decreasing. But if you look at it, this is multiple model projections. Even towards the end of the century, even though on average the ski season's 2 months shorter, you could get a really cold, wet year where you're getting as much snow as we used to get in the 20th century, right? And it's a double-edged sword. You see the opposite too, where you have a ski season that instead of about 5 months is as short as about 2 or 1.5 months long, right? So that's one. The other ones that I didn't mention is Julie mentioned that changes in the uplands are starting to be recognized as really important and something that we ought to deal with. And a big one there is sediment. And I don't want to steal Eric's thunder. He's going to talk about that a little bit. But we have done some research on that, but there's not a lot of research that really is sort of end-to-end. Not only how much more sediment is in the river, but where is it going? And so there's a little bit to show that as you have higher flows, you're going to expect to deliver more of that into the rivers, and that's going to be really important. And there's some great examples coming out of USGS in particular where they've looked at just how much the river channel has changed. And I think I'll stop there before Eric makes me stop. But there's others too. So we expect wildfires to risk to increase. Wildfires are rare west of the Cascades, but they're projected to become more frequent. And even in the absence of wildfires, we expect other things to change as the climate becomes less suitable to the existing populations of tree species and other things up in the uplands. So those are going to have a really big impact on what happens in our floodplains, and those are really not well quantified. Okay, so I want to I've talked a lot about just sort of the drivers, and understandably, the point of this project is not to understand better the physical mechanisms causing flooding to change. It's what actually is going to happen and what can I use in order to plan for this, right? So this is kind of a neat picture, by the way. This is, what's going on there? This is the city of Snohomish, just north of Seattle, and this is before they put levees in a flood in 1909. But pretty significant flood. There's the valley there is basically really flat, and so a 100-year event, actually with or without the levees, basically floods the whole valley. And I actually don't remember what magnitude of an event this is, but it's actually not that common to have substantial portions flooded in these kinds of events. So we looked at that and asked, okay, this is fine. We've got more water in the river, but who cares if you can't actually know what gets flooded and what doesn't, and start to think specifically about the implications on the landscape. So one easy way to do that is to just ask, we know what the 10-year or the 100-year event looks like because we've got FEMA and planners who are looking at those kinds of events historically. So how much more often is that same event going to happen? You can take your historical map of the 10-year event and then you can just rename it, right? And so if you're going to do that, you would say the 10-year event by mid-century, by the 2040s, so just a couple decades away, is now actually a 5-year event. It's happening twice as often. If you look at the 100-year event, it's more like 3 times as often. It's now a 30-year event. And this is mid-century. It's obviously more frequent as you come to end of the century. That's one way to look at it. It's sort of the cheap and dirty. You've got these maps already. Just write a new number on the top, right? It's not the 10-year flood map anymore. It's the 5-year flood map. Another way is to run hydraulic models. This is another way we did it. We looked at these hydraulic models that FEMA and others use to map out where it actually gets flooded and how deep. And I don't want to get too in detail of this, but the point is these are two different scenarios. Again, mid-century, and the blue are areas that used to not be flooded during the 10-year event, but now are projected to be by mid-century. So there's a range among the projections, but the point is more areas get flooded. We have other maps that show you how deep that is in these different places and how much deeper it is where it's already flooded. So these are the kinds of things that actually you could maybe think about sitting down with a planner and looking at the map, looking at land use, thinking about planning and how you might use that. So that's sort of what we're working towards. Okay, so I've mentioned a lot of this. I just wanted to throw it up and say, the whole point of this project is to think really specifically about the implications. So I mentioned the ones on the top, and I want to mostly highlight on the bottom, we are talking about multi-objective floodplain planning. So we're not just talking about floodplain management, land use planning, we're also talking about agriculture, how are they affected, and it's probably different metrics and things that are of interest. We're also interested in salmon recovery and what is of concern to the tribes and how we can look at that. And then I want to talk about just where we're going. This is sort of the first task of this project. The next steps, once we have this report completed, is to start looking at some of these infrastructure projects that are already on the ground and going. Is there some information that we can plug into those projects that would allow people to at least incorporate some considerations regarding climate change into the design of those projects? So similar to what they were talking about before with bank full width, are there some design considerations? Given that they've already going to implement these projects and they're going to be around for decades to come, what could be done differently? And then we've got a whole bunch of things that we're interested in doing down the road, and sort of musing on. Like we did some of these 2-page summaries that Julie was mentioning. So for the Stillaguamish watershed, we had a 2-page synthesis of the impacts for that watershed, and we did the same for the Puyallup. We could beef those up, do something more interesting with that, and we're sort of starting to think about how we could do a more tailored type of work that really gets at what are the considerations that people need, what are the numbers that people really need to be using in terms of planning around this. Okay, I'll stop there. I think I've talked more than I needed to already, so if there's any questions, and otherwise I can answer things during the discussion time.